Okay, Assalamualaikum, good afternoon. So I have 41 like or react to the video. Don't forget to take your selfie during class. My PhD students, if you are here, also send me your photo. Also, you can put in your progress report, okay? That you attended the class. Alright. So first I will go through row space and column space, and then the second half I will discuss about the test 2, yeah, the sample. Okay. 3.8 page 2. Okay, just to make sure that you can see. Dia ada lag sikit. So row space and column space. Okay, so this is of a matrix. Now our matrix A, okay, A11, A12 until A1n, A21, A22 until A, just 3, right? 2n up until A M1, AM2, AMN. Okay, so this is our regular matrix, M by N, right? M rows and column. Now the row vectors, we call it row as the row vectors. Okay, so it's just A11, A12 until A1n. So this is 1 by n. R2, A21, A22 until A2n. Up until how many? M. Okay, M, because we have M rows. AM1, AM2 until AMN. So they are called the row vectors. Then we also have the column vectors. So I call the column vectors as C1. So we write as column A11, A21 until AM1. Column 2, A12, A22 until AM2 until CN. Okay. A1n, A2n until ANN. So this is called row vectors and column vectors. Now, what is row space and column space? So row space is the subspace spanned by the row vectors, and the column space is the subspace that is spanned by the column vector. So row space is span of the row, and column space is the span of the column vectors. one example given in the book. Okay. Alright, A is given to be 241 314 555. Okay, so row space is the span of these three rows. Okay, row space is the span of these three rows, which is actually in R3, right? This is in R3. So this is V in R3. V is the linear combination. What is this? This is actually a subset of R3. Okay. Is it the whole of R3? What is the span? Or is it a subset, a subspace of R3 can be a plane. Okay, it can be a plane. It can be also a line. It can be also a point, right? Okay. A point 0, 0, 0. It can be a line. This is three-dimensional. It can be a plane. So how do we know what is the span of this? Okay. The one given in the notes. I explain what is given in the notes. This is actually a combination of these two. Okay, so this set is actually not linearly independent. Alright, we take this out. The span of the whole thing is the span of these two. Right, but this is easy to see. What if it's not? So what I will do is I go back to the earlier section. I put 241, 314, and 555, and then I want to see whether it spans the whole R3. Okay, this is the easiest way to find the span, right? So we row reduce. So we take R1 with R3, right? Okay, can everyone do this? Because it's not in the book. Is it in the book? No, it's not. Okay, you can write this out. Okay. So we have 1, 4, 5, Z. Just change, right? 2, 3, 5, X. 4, 1, 5, 1. Okay, so negative 4 R1 plus R2, negative 2 R1 plus R3. Okay. Kat mana hujan lebat tu? The live video will be there, so if in any day or any time that you miss, you can go back. You can find the exact time that you missed. I have asked Kak Hana to help me downloading also the video in the e-learning, ya. Because lepas event tu habis, takut dia tak save. Okay, so 1, 4, 5, Z. Okay, 0, negative 4 and add, negative 4, negative 16, negative 15, negative 20, negative 15. This one is negative 4Z plus Y. Okay, then negative 2 and add, negative 8 and add, negative 10 and add, negative 2 and add. Okay, and then you can do negative 1 over 5. Well, before I do this, okay, before I do this, let me just don't do fraction, because if I multiply by 1 over 5, this become fraction, right? Okay, tak cukup kuat macam dah kuat je. Is it my phone yang tak kuat ke apa? Sekejap. Oops. I think it's okay, right? Ke hujan yang tak kuat ni? Okay. Clear kan? That is clear. Okay, so saya ulang, ya. Before I multiply this 1 over 5, this will become one fraction here. So why not we just multiply this by negative 3 and add to R2, okay? Because then we don't have any fraction. Akmal, is it okay now? Okay, 1, 4, 5, Z. Okay, I change R2, yeah? So I don't change this yet. Okay, normally you do it on the row below, right? Then you're asking me, why do I do the row on the top? Because why don't I make this 1 first? Okay, the reason is because I don't want any fraction before. As long as, because when I do this, multiply by negative 3, which is 15, when you add this becomes 0. And then later on I can make this 1, okay, by switching. Okay, negative 3 and add, negative 3 and add. Okay, now negative 3 and add. So I get negative 3x, okay, plus y. Negative 3 and add, y is here. Negative 3, 6, add. Okay? Okay, if you really, you can stop actually here, because what I want is this, right? But just to do it properly, I just do until the end, yeah? Okay. So what I do is, I change row, and then I do another one. I do negative 1 over 5 R3. Ni illegal tapi saya nak save space ya. You have to switch first, and then you do this. Saya buat sekali kat sini. So what you get is 1, 4, 5 Z 0, 1, 1, yeah. Negative 1 over 5, negative 2Z plus X, then 0, 0, 0, negative 3X plus Y plus 2Z. Okay. Now, if the rank is 3, it means it span the whole R3. Okay, it span the whole R3. If you check the determinant is 0. Okay, because this column is this plus this. Or from here, the determinant is 0. So meaning it does not span R3. Okay, what does it span? If this were 1 or number, then the rank is 3, then it span R3. Now since the rank is 2 and you have the last one, the basis will be just these two. Okay, meaning you just take the first two as the basis. Yeah, this one is not a part of the basis because the first two, and this is also a part of these two. So span, what do we call it earlier? S, right? S, if S is the row space, okay? Span of S is span of this, which is X, Y, Z in R3, such that negative 3X plus Y plus 2Z equal 0. Okay? So this is how I get the answer. Span of S is negative 3X plus Y plus 2Z equal 0. So the question is, what is the row space? Okay? What is the row space? Now, if I ask you, what is the basis of the row space? Okay, what is the basis of the row space? The basis of the row space will be these two. Okay, so you take from these two. So that is the next question I can probably ask. Okay, because this one, there's two variables, right? Okay, so span S is actually span of just R1 and R2. Just R1 and R2. Okay, now for column space is a span of the column. What are the column? 2, 3, 5, 4, 1, 5, 1, 4, 5. Okay. 2, 3, 5, 4, 1, 5, and 1, 4, 5. Okay. Okay, again, you do the same thing as before, then you can see whether the span the whole R3 or not, because this is also R3. Okay, but it's in the terms of the column. You can check the determinant. If you check the determinant, okay, check the determinant. This is 10 plus 80, right? 10 plus 80 plus 15 minus 5 minus 40 minus 60. Okay, so 105 minus 105. So that is 0. Meaning this is not independent. This is dependent, meaning you can get rid of 1 or 2, but you can get rid of 1. Which one to get rid of? So this is not, the span is not R2, it's a part of R2. So what you do is, you just write 235, 415, 145, X, Y, Z. Huh. Okay, so what's the easiest way? What's the easiest way to get 1 here? You don't want to multiply by 1/2, okay? Okay, so any suggestion? Can you type? How do you get 1 here? There are many ways to get 1. Okay, cepat bagi suggestion. Negative R1 plus R2. Okay. This is okay. Then at least you get 1, right? Or negative 1. Okay. So negative R1 plus R2. So 2 for 1 X 1 negative R1 plus R2. Negative 3 negative X plus Y. And then copy. Alright, next we change the row. Okay. Negative. You. Okay. Okay. You remember somebody. Okay. Somebody write this. Shake. Negative R3 plus 2R1. Okay, this is violating the rule. Our rule is KRI plus RG. Okay, this is changing the RG, but you multiply by K in the first one, you never multiply in the second one. This means already 2 operation. Okay? So you cannot do this. You can do it 2 times, but no. So here we have 1, negative 3, 3, negative x plus y, okay, 2, 4, 1, x, 5, 5, 5, z. Okay? You imagine before this, it's always easy, right, to get 1. In this problem, you have to go through 2 operations and you get 1. Okay? Negative 2 r1 plus r2, negative 5 r1 plus r3. So you see, this section is just, you have to know the definition of row space and column space. The working is just like the previous section, right? The working is just like finding the spanning, finding the basis, and this. Okay. So 1, negative 3, 3. Negative 2, row 1 plus row 2. 0, 10, negative 5, okay, negative 2, 2x plus x, 3x, minus 2y. Okay, and negative 5, r1 plus r3, 0, 20, negative 10, 5x, minus 5y plus z. Okay? Now you see, before you make this one, you make this 0 first. Right? Give me a suggestion. How do you make this 0? Cuba type. How do you make this 0 from here? Ada jawapan tak? Dia nak cuba. Okay. So, negative 2 r2 plus r3. Yes, Akmal is right. Okay. Negative 2 r2 plus r3. So we get 1, negative 3, 3, negative x plus y. You don't need to make this 1 first, okay? You remember the rule for row echelon or row reduce, right? I normally will start with taking 1, 1, and then 1, and then 1, right? But in some cases, you don't want fraction. You can do it, make it 0 first, then 1. Okay, like this one. Okay, negative 2 r2 plus 0, 0, 0. Okay, negative 2 r2, negative 2, and add. Okay, negative x, y, Z and X. Okay, so span of the column is V in R3, okay, negative X, oops, sorry, I better put V equals X, Y, Z in R3, negative X minus Y plus Z equal 0. So this is a plane, okay, this is a plane. And one basis, there are two ways to find a basis. One, you can solve this and get two free variable and get two bases, but you don't need this because you already can get the first two, okay, these two. So you can, the basis of the column space, actually you can take any two to be the basis, okay, because they are not a multiple of the other one. Definitely one is out, okay, definitely one is out because you only have two free variable, okay. In the book I mentioned that one is a multiple of the other two, but you can take any one out. So this can be a basis, this can be a basis, this can be a basis, right? So you can take any two. So I can write a basis is 2, 3, 5 and 4, 1, 5, or any two, okay? So I will write here, there is a blank space, page 214, I didn't write this. You can fill that out. Okay. So when I put, it's the span, so you have to do all this row operation to get the answer. And then when I put the answer, the span is 145 and 235. It can be also these two, it can be also these two, okay? So it's not unique. Okay. Elementary row operation does not change the row space of a matrix. So the basis can easily be found if we reduce the original matrix to upper triangular or row echelon form, okay, with the elementary row operation. Non-zero rows form a basis for the row space, and also non-zero vectors form a basis for the of theorem 330. Non-zero row vectors in row echelon form a basis. Okay, what does it mean by that is, after you reduce, for this one, this is column, right? So this is column, this one, and the what it said is for the row space. I already erased, but you can just take the, you remember in the row space there is also a 0, 0, 0. So just now in the row space you just take the first two, that becomes a basis too. Okay, so the rest you can follow through. Okay, row space, example 3.35. Okay, this section is actually quite simple. Okay. Example 3.35. You are given already the vectors. Okay, find the basis for the vector space that are spanned by the vectors. The question asks you to find the basis. So if there are two ways to solve this. First, you make it as column. One way before, what we do is we write like this. Alright. Here's number 2. Okay, before, if we given this as a vectors in the set S, we write as column, and then we reduce, right? We reduce until supposedly RREM, and then we choose the column that has the non-zero, the leading one, right? The leading one. Suppose when we reduce, you see this is 1, 2, 3, 4, 5, but only 4 column. So at most 4 leading one. Then you choose the leading one, and then you just take the original vectors, right? As the vectors. For this one, the difference is I write as row, and then you reduce, and you just pick the non-zero rows as the basis. Okay, so we will do this both ways, yeah? This is the way before. Well, let me double check. 1 negative 2 0 0 3 2 negative 5 3 6 0 5 15 10 0 6 18 8 6. Okay, let's do this. Semua orang boleh buat sendiri lah. Okay, 2R1 plus R2. Okay, ni dah kosong-kosong kan. Negative 3R1 plus R5. 0. Negative 1. 5. 10. Okay. 0, negative 3, 15, 18. 0, negative 2, 10, 8, 3, 6, 0, 6. Okay. Negative row 2. One, 2, 0, 2, 0, 1, negative 5, negative 10. Negative row 2. 0, negative 3, 15, 18, 0, negative 2, 10, 8, 3, 6, 0, 6. Okay, next. 3 row 2 plus row 3. 2 row 2 plus row 4. Negative 6 row 2 plus row 5. Try to use the same row, although you can also use this because the row is changing. Okay, don't use other rows. Okay, so 1, 2, 0, 2, 0, 1, negative 5, negative 10. 3 row 2 plus row 3. 0, 0, 0, negative 12. 0, 0, 0. Negative 12. Ni bukan dalam buku. I was saying this is the method that we used before. Okay, after this I will give the other method given by the notes. Then that will answer Akmal question. Why in here I transpose then ERO, right? Okay, itu belum lagi lah. This is before. Okay, there are two ways to solve this. because you see the question did not say about the row space. The question is find the basis for the vector space that are spanned by the vectors. So this is the way that we did before. Okay? Sabar. Last one. Apa jadi tu? This is 0, kan? Right? Ada siapa tak yang salah salin tu? Negative 3R1 plus R5. Okay. Negative 6R2 plus R5. Negative 630. Okay. 66, right? Okay, you see these two are the same. And this one you can change here. Okay. So you will see that one more. Row 3 and row 5. Okay. Saya cut short sikit lah This one habiskan. Saya put 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 1, negative 1, negative 10. Alamak. Right? So these two, it becomes these two. Okay, this becomes this. Okay, and then these two. So you see 1, 1, 1, 1. Okay, so meaning you just take sorry, not this one. I want the row, right? So you have 1, 2, 3, 4. Three or 4. Satu, dua, tiga, empat. Four out of let me think. Okay. The one that I miss here is to see the spanning, right? We have to have x1, x2, x3, x4, x5. Okay. And at the end, okay, this says this says that it does not span the whole of R1, 2, 3, 4, 5, right? It does not span the whole of R5. What I'm trying to say is, this is what we did before to find the basis, right? We write as column, and then we reduce, and then we find the how many space, how many leading one for the basis, okay? But in this section, whatever is given, we don't change. We write as rows, and then reduce, and just pick up the rows that is not 0. That's it. The basis for the row space. That's the point. So when it comes to the basis of the row space, you don't need to transpose like you asked before, right? This is from before. If you are asked to find the basis of the span, if to find the basis of the row space, so if you are given as a row, you will write row 1, row 2, row 3, row 4, okay, as row. Okay, page 216. Write as row, and then you reduce, and then you get 1, maybe 0, 1, 0, 0, 1, 0, 0, 0, 1, whatever here. Oops, I think the last one is all 0, right? Yes, right? So you just pick as the basis, which is easier actually, right? So that is page 216. For the basis of the column space, then you transpose. Alright? So example 3.36, basis for the column space, you transpose, you reduce, then you pick the leading one, then you transpose again. Alright? So let me come up with one example. Example 3.36 is not really nice because it's 3 by 3. You don't see it as whether it is row or column because it's 3 by 3. Okay, let me see. Okay, this is good. Example 338. Okay, so we have this matrix 1, 2, 3, negative 1, 0, 1, 2, 1, 0, 2, negative 1, 0, negative 1, 1, 2, 0, 1, 2. Question is, find a basis for the row space and a basis for the column space. Okay. For the row space, we just reduce. Okay. So negative 2, row 1, plus row 2, row 1, plus row 3. Zero, negative 3, negative 6, 2. Okay. Negative 2 and add, negative 4 plus 1, negative 6, 0, oops, 4, right, negative 1, negative 2. just add 0, 3, 5, negative 1, 1, 3. Okay. Okay, now just add this, right? R2 plus R3. If you make it 1/3, then you will get fraction. So 1, 2, 3, negative 1, 0, 1, 0, negative 3, negative 6, 4, negative 1, negative 2, 0, 0, negative 1, 3, 0, 1. Okay, since this is not yet row echelon or row reduced, but this is like almost triangular, you can stop here. You can further on and make this 1, and then get fraction, make this 1. Or you can just stop here and say that you can actually get a leading one from here. So this is your basis. So the basis of row space is any 3, right? This is okay, this is okay, this is okay. Okay, so the answer is not unique. A basis for the row space, I put it there, is this 3 or the original one. Okay, or if you put this also, is okay. Okay, now this is a subset of, okay, this is a subset of R6. Okay, R6. Now how to find the basis of the column space? Column space is, sorry, saya lupa charge, nanti kan mati lagi. Sekejap ya. Charge my phone. Yang mana tu? Afika, dari awal yang row 5 bukan semua 0? Which one is that? Which dari awal row 5 semua 0? Soalan ni ke? Row 5, tak nampak ada row 5 pun kat sini. Which one are you talking? The column space or the row space? Yang ni tak ada row 5. Okay, let me do this for column, ya. Okay, so to find the column space, you have to transpose. Okay, the original matrix, you transpose. Okay, so 1, 2, 3, negative 1, 0, 1, 2, 1, 0, 2, negative 1, 0, negative 1, 1, 2, 0, 1, 2. Okay, yang ni saya skip, tak ada kat situ. So you reduce this and find the basis. Banyak sangat pakai row reduction kan. Soalan tadi, or the one that I showed earlier. Oh yeah, betul. Yeah, that's why I get only 3 kan. Later, you WhatsApp the correction ya. Ada satu tu all zeros kan. That's right. So then we left with 3. Okay. Okay, so reduce ni. Panjangnya. Negative 2 row 1 plus row 2. 3. Negative 3 row 1 plus row 3. Row 1 plus row 4. Negative row 1 plus row 5. Zero. Negative 3. 3. 0. Negative 6. 5. Okay. 0. 4. Negative 1. 0. Negative 1. 1. Oh, I make negative 1, 2, 3, 4, 5. 6 ya. 6. Negative row 5. Terus. Okay, 0. Negative 2. 3. Okay, saya ubah sikit ya. Okay, because this is a multiple of 3, so this one is 1 minus 1/3 R2. But you can also do this, right? R2 and R5 kan? Okay, this one I don't have to calculate anything. 1, 2, negative 1, 0, 1, negative 1, 0, negative 6, 5, 0, 4, negative 1, 0, negative 3, 3, 0, negative 2, 3. Okay. Dah selfie belum? VC nak tengok. Famous satu UTM. 1, 2, negative 1. Okay, now. Okay, 6 and add, right? 0, 0, negative 1. 6 and add. Okay, and then negative 4 and add. 0, 0. 3. And then 3 R2 plus R5. 0, 0, 0. And then 2 R2 plus R6. 0, 0, 1. Okay, and then last one, yeah? Last one. Belum last one lagi, last one. Then at the end you will get this 3 kan? Okay, you add this 3. So the basis of column space it has to be the original column. The original column is R3. Okay, so you take the first 3, because it's, and transpose again, then take the column. So 1, 2, negative 1, 0, 1, negative 1, 0, 0, 1. So this is the basis of the column space. Instead of 1, 2, 3, 4, 5, 6 becomes only 3. Basis of the column space. So basically this is the column space and the row space. And the last one that I want to mention today is about the null space. Okay, the null space is another one in which page 220, definition 315, a null space of a matrix. The null space of m by n matrix is the solution V AV equals 0. So A is m by n matrix. Null space of A is V AV is 0. Okay, V, if A is m by n, V has to be n by 1, right? So this has to be in Rn. And this is the 0 matrix, okay? M by n, n by 1. So this is actually solution of the homogeneous system. Go back to chapter 2. Ish, dah ada basic jam lah. Sekejapnya. Okay, go through example 3.39. You go through yourself because this is chapter 2. This is chapter 2, solution of homogeneous system. Yeah. Okay. I will stop here for the lecture because I want to go through the test. Next week we don't have class, unfortunately, because Sunday is ganti the. Tomorrow we have Labor Day, which is a public holiday. Okay. The public holiday on Friday, it brings to Sunday, and Thursday is Wesak Day. Okay, so no class next week. And then the following Sunday, then we have test on Monday, right? Yeah, so we'll still meet on Sunday before the test, right? So the test will cover until transition matrix, chapter 3, vector space, subspace, linear independent, spanning, and transition matrix. Okay, alright. Okay tak? Alright. Okay, sample test. This was, when was it? Last year. M is x plus y. X bigger or equal to 0. xy in R. X plus y. X bigger or equal to 0, xy in R, with the usual operation in vector space R2. Usual operation meaning additional and multiplication by scalar. Determine whether M is closed with respect to addition and scalar multiplication. That's the first question. Determine whether M is closed under addition The second question is under scalar multiplication. State the zero vector and determine whether there is an inverse for AB. Okay, so let U to be x, x plus y, okay, you can use x1, right? V is x2, x2 plus y2. So x1 bigger equal to 0, x2 bigger equal to 0, x1, x2, y1, y2 is R. This is very important, okay, because this is the condition of x and y. So you have to write it down and check. Now, what is u plus v? U plus v will be x1 plus x2. You have to show it is in this form. So you add x1 plus x2. This one is x1 plus y1 plus x2 plus y2, which is equal to, because they are just real numbers, you can do like this, right? And you also have to mention that the first one is bigger equal to 0. So since x1 is bigger equal to 0, x2 is bigger equal to 0, x1 plus x2 also bigger or equal to 0, because this is okay. And also they're all reals. Real number plus real number is also a real number. So x1 plus x2, y1 plus y2 is also, this has a mark because that is the condition. Sometimes it's not true, so you have to check. Okay, you remember the example I gave before? If they are in different quadrant, when you add, they are not in that quadrant. So that is sometimes it does not satisfy this. Okay. Is it closed under scalar multiplication? What's the answer? So the answer here is yes. Determine, right? Now, is it closed under scalar multiplication? Okay, so if u is x, x plus y, x bigger or equal to 0, xy in R, ku is kx and kx plus y, right? Which is kx, kx plus ky. So this is in the form of x, x plus y, x, x plus y. This is okay. But when x is bigger or equal to 0, kx might not be if k is negative. Kx will be negative. Okay. have a problem here. Okay, we have this problem, meaning it's not close. Okay, because k can be negative, right? Clear? Okay. Yang paling senang is you can also give an exact example, like u equals 1, 2. Right? This is okay, which is 1, 1 plus 1. Then, so x is 1, y is 1. Okay? If k is negative 1, ku is negative 1, ku is negative 1, negative 2. And it does not satisfy anymore that x is bigger or equal to 0. Okay? X is less than 0. So ku is not in M. So the answer here is no. Okay? Alright. Next. Satu soalan ni banyak sangat nak cucu cicit ni. State the zero matrix. So x plus y plus ab equal x plus y. This is 0, right? If you add, you get it back. Okay. So what is a and b? You solve this, you get a, b is 0, 0, right? Okay. So 0, 0 is in M. When x is 0, y is 0. When x is 0, y is 0, yes, it's okay. 0 is bigger or equal to 0. And also, y and x is in R. You imagine if I change the question without this, there is no zero vector. Okay? So, I can give you a very similar question to this. Just change it a bit, it becomes totally different. There is no zero vector there. So in this case, yes, but you have to check whether this is in M. Yes, this is in M. Okay, last one is to find the inverse. The inverse is when you add, it becomes zero vector, right? So x plus y plus, what is this? AB is 0, 0. So you want to find AB. So AB is just negative, right? Negative x minus y. But is this in M? No. Okay. Because negative x might be less than 0. Okay. For example, you have 2, 4, right? 2, 4, you add what until you get 0, 0, you need negative 2, negative 4. But it's not in M. Whatever in M, x has to be non-negative. But this is negative. So the answer for the last one is there is no inverse. Because for this to be equal to 0, 0, you have to get this, but this is not in M. Okay? Alright, nak markah banyaknya. Number 2, I think there's no problem. Show it's a subspace. So you just show it is closed, right? And the addition and multiplication, the 2-step. 0, 0, 0, 0 is in there. Addition and multiplication is easy. Okay, number 3, we just did number 3 just now. Describe the span, right? So for number 2, okay kan? Number 3, to find the span, you just do 1, 2, 0, negative 1, 1, 1, x, y, z, right? Then you reduce. So negative 2 row 1 plus row 2. And one more. Tukar R2 and R3. So you have 1, negative 1, x, 0, 1, z, 0, 3, negative 2x plus y. One more, negative 3, R2 plus R3. 1, negative 1, x, 0, 1, z, 0, 0, negative 3, negative 2x plus y minus 3z. Right, so that is your span. So span S1 is V in R3, yeah? Oops. V equals x, y, z in R3. Even if you don't write V equal, it's okay. This, yeah? Negative 2x plus y minus 3z is 0. Try this. It's a plane, right? It's a plane. Okay. Okay. Now number 4. Show S2 is not linearly independent. Okay. Tak ada tanda soal. Show tak ada tanda soal. Okay. You see, this is in R2, but there are 4 of them. Okay. So definitely too many. Even the second one is a multiple of the first one, and the third one is a multiple of the first one. So you can see, dengan pemerhatian sahaja, just by looking, you can just take the first one and the last one. That is the subset, which is linearly independent. Okay, you can just, tapi takkan tak ada jalan kerja kan? Takkan nak jawab by looking. So S2, tak payah saya soalan lah, semua ada soalan. What we can do is we can reduce 1, negative 2, negative 1, 2, 4, negative 8, negative 2, 1. 1 reduce 2, R1 plus R2. 1, negative 1, 4, negative 2, 0, 2 and add, 0, 0, negative 3. So you will pick these two. Okay, so S3 equal the first one and the last one. Okay. Oh, tadi show that S2 is not linearly independent. Saya dah padam pula. Tak padam lagi. Okay. Okay, you have to write the definition, Okay, S2 is linearly independent if C1 U1 plus C2 U2 plus C3 U3 plus C4 U4 equals 0, imply C1 equals C2 equals C3 equals C4 equals 0. You had to write that for a mark. Okay. Show that S2 is not linearly independent. S2 is linearly independent if the linear combination, ni penting jangan tertinggal. If the linear combination equals 0, okay, can you show that all the coefficient is 0? Okay, so ingat tadi cari basis of span, silap So you put this and you put this. Sekali lagi, you will get 0, 0, 0, 1, 0, 1, 91, 4. You can put this 0. Okay. So from here, you can say that, okay, C1 is 0, C2 is 0, right? C3, C4 is 0. C1 0, C4 0, C2, C2, C3 free variables. Okay, so C2, C3 free variables means they are not all 0. Not all Ci is 0. So S2 is not linearly independent. Okay. This is compulsory. Then you do this, put 0 at the end, and then solve chapter 2 and say there are free variables, so it's not unique. Unique means all 0. This is not unique. There's many solutions. So there's free variable, not all 0, so it's not linearly independent. And then find a subset which is linearly independent. The subset is the one that has the leading one. So just take the first one and the fourth one. Even you want to check the determinant is negative 3, right? Negative 0. Okay. Question number 5. Remember, this is only 1 hour and 15 minutes. Question number 5. There are 4 vectors, matrix 2 by 2. Determine whether it's a basis or not. Okay. You remember the definition of test 2 will need to be an open book, because you are at home. How can I say don't open your book when you were there? We haven't discussed about how test 2 is going to be. Should be like test 1, okay, but you are not in the classroom, so we are still thinking how to do it and what's the direction, right? Even if it's open book, even if the book is there, you have to write what it means accordingly to the question. Okay. Now, S4 is a basis if it's span M2 by 2 and linearly independent. So if there exists C1, C2, C3, C4 such that the linear combination is equal to the vector, and S4 is a basis of M2 by 2 if it spans and linearly independent. Okay. S4 spans M2 by 2 if for all, I can use A, B, C, D or W, X, Y, Z. In M2 by 2, there exists C1, C2, C3, C4, and R such that Okay, and linearly independent if all is equal 0 implies C1, C2, C3, C4 is 0. Okay, now we to find C1, C2, C3, C4. This is chapter 2. For matrices, you can do this. 1, negative 1, 0, 1. 2, negative 2, 0, 2. 2, negative 4, negative 7, negative 3. 3, negative 1, 5, 6. Okay, and then put A, B, C, D. Okay, one way to see whether C1, C2, C3, C4 exists is, since this is 4 by 4, you can find the determinant. Find the determinant. Okay, what I will do is, at least I do row reduction once. Alah, padam pula. 1, 2, 2, 3. Okay. So R1 plus R2, negative R1 plus R4. Okay, 1, 2, 2, 3, 8, 0, 0, negative 2, 2. 0, 0, negative 7, 5C, 0, negative 1 and add. 0 again, negative 5, right? Negative 3, 1, negative A plus D. Okay, this one looks nice. Can just make it a half. Tak apalah sikit lah kita buat fraction lah. Okay. Okay, so 1, 2, 2, 3, 8, 0, 0, 1, negative 1. So multiply by 8, hilang pula. Negative 1 over 2 R2. So negative, okay, 0, 0, negative 7, 5C, 0, 0, negative 5, 1. You realize that we have been doing row operation for the whole, almost, except for number 1 question. Nampak tak apa yang penting? Okay, one more. 7 row 2 plus row 3, 5 row 2 plus row 4. Saya berhenti, semua jangan berhenti. I wait for you to finish. Okay, 0, 0, 7 and add 7, negative 2, okay, 7, is really double. Okay, 5R2 plus R4. 5R2 negative. Conteng kita conteng. Okay, 5R2 plus R4. So this is negative 5 over 2 plus negative 2 over 2, negative 7 over 2b minus 5 over 2b plus d. Okay. One more. Okay. You can make this 1 if you want, but lagi susah nanti, kan? You just do 2 row 3 plus row 4. Negative 2. Okay. I just leave this first. 0, 0, 0, 0. Negative 2, row 3, that will be 2, 7a, negative 2 plus 7b minus 2c, then I have plus R4. Add this, 7 over 2a plus 7, oops. This one is 14 plus 9 over 2b minus 2c plus d. Okay, so dah dapat. Actually, tadi saya bukan nak habiskan ni sebenarnya. Saya nak cari satu aja row operation and determinant, tapi dah terlepas, tak apa. You don't have to do this, you just have to find the determinant. Okay, determinant A is 0 implies CI does not exist. Therefore, case 4 does not span M 2/2. Sebab kita rasa kenapa sangat susah, kan? You don't have to do all this. So from the very beginning, when you get the matrix A, maybe just reduce one, or don't need to reduce, but find determinant. Okay, get the matrix A, get the definition of spanning, get the matrix A, show that the determinant is 0. I know it's 0. So CI does not exist, it does not span, so S4 is not a basis of M 2/2. If they want, what does it span? Baru we need this, right? But this is too complicated. Okay. So question 5, actually what you have to do is to write as a matrix 4/4, find the determinant, and mention that since determinant is 0, this one, yeah? So it does not span, so it's not a basis. If you just write this, and then this, tak ada markah, eh? If you just write determinant is 0, then terus cakap not a basis, tak ada markah, because you don't understand the real situation. Okay, because it comes from the spanning and for the coefficient. Okay, for the last one, you are given the transition matrix. You have to find the vectors. Okay. Yes, true. Elementary row operation memang kena perform. I mentioned this so many times, and for those students who did not perform in test 1, there are about 2 or 3 of you that really need to do lots of exercise for row operation, right? Because you can see so many of these rely on row operation. Okay, for transition matrix, from S to S prime, right? So the formula is Vs prime is equal to P Vs, right? Okay. Okay. Oh, now you are given as S. So V of T prime equal P V of T in number 6. You are given the vectors for T, okay, and you are given P from T prime to T. This is S to S prime, right? Okay, double check which page is it. Okay. Okay, this is page 201, 200, P transition matrix from S to S prime. Okay. Okay, putih ya. Okay, now P from T to, wait, they're given from T prime to T. Okay. I change this, yeah. T prime to T, so this has to be T prime, this has to be T. Okay. And T is given to be 1 minus x, 3x, x squared minus x minus 1. question is find T prime. Oh, you given the P. P is given to be 1, 0, 1, negative 1, 2, 0, negative 2, 1, negative. Any of you have tried this or not? Any of you have tried this or not yet? Second one is if v for x squared minus 2x, find vt using vt equal p vt. This one is quite straightforward. You just have to find the coordinate matrix of V relative to T prime, right? So you have to find Vt prime. You try for part 1, I will show you part 2. Find Vt prime. For x squared minus 2x equal okay, this depends on your first part. Okay, in your first part, if you call this as u1, u2, u3, okay, this one you have to find c1, u1 plus c2, u2 plus c3, u3. If you already found this, you can find c1, c2, c3, okay, and then you can equate this, then you can multiply by p, then you can get the answer. Okay, so I want you to try first. I think many of you have not tried yet until number 6. Okay, we can discuss this over WhatsApp, alright? Any of you who already get the answer, share with me, share with us, so I will check. Alright, okay, so it's 4 o'clock almost. Anybody has not yet scanned your attendance at the top?